showing the loop to, you know, of maybe natural gas in the boiler, BTUs in, BTUs out, and a recycle loop of BTUs based off that SynGas that comes back to your boiler. Just almost just an energy balance right there, but in a drawing form. It would help to explain to everyone a little bit better how that works.
Got a question on your charts. I like these flow diagram concepts you got here. Whose software you use to make these flow diagrams?
Microsoft.
Huh?
Microsoft.
They're made in Visio.
Visio and just in PowerPoint itself.
It's in PowerPoint?
Mm-hmm.
Oh, I guess mine is pretty old. Yeah, that's good.
I'm not an engineer, but I just was curious about water requirements coming in, going out. The only one I noticed with any possible water going in might be the gasifier with the steam. Where I'm going with this is what kind of pollution burden do you have on any water that goes out of this system? And maybe that's all well known, and maybe that's all for all gasifiers the same, and that sort of thing. That's why I'm not an engineer, especially not here, but just that and the air quality. Because I'm thinking California, for example, would want to know these things.
As far as like thermal pollution from the water, anything that comes in is either condensed and sent back to the boiler, or is used in, say, here in the plant.
Yes.
So the pollution remains the same as, basically the same as it would if they got the steam from anywhere.
Any boiler.
Right. Otherwise, the water, right? The water is a closed system.
Okay.
So thermal pollution to streams or anything like that would be negligible.
So it's just the exhaust, as in air. And Tiffany already touched on that.
Josh, what happens to the steam that goes into the carpet dryers?
The steam that goes in there?
Yeah, is it?
Oh, it gets condensed and run back through the system.
It's condensed as it goes into the waste system and flows out to
Okay.
the
So
sewer.
it comes out as water. I mean, it doesn't stay with the carpet. Carpet's not wet when it comes out.
Oh, it is wet. We suck a lot of it out, and then when we can't vacuum out, we actually run through a big box with gas burners in it and dry. Most of it comes out, condenses out in the steamer, just goes down in trenches and flows out of the plant to the
That's sent to like a POTW or wastewater type thing, not recycled to the boiler.
Not yet. No, the problem with that is
there are a lot of like pollutants and
there's a lot of spin finish and yarn finish and yarn chemistry in the water, and it really messes up the boilers if you try to send that back to the boiler. So we just flush it down the drain. We do reclaim the heat out of it because it goes out about 130 or 140 degrees, so we do bring in our incoming water reheated with outgoing water, reclaim that.
I mean, I noticed the chemistry in the boiler. I'm not the foremost expert, but there's a lot of chemicals they're putting in there to maintain the boiler, to keep it from corroding and stuff like that. And we have to, one facility I work at actually feeds 2 plants, and both plants run on slightly different chemistry for dyeing of the carpet. So we have to be mindful of the chemicals we have in there and the levels they are, because they will affect the actual dyeing of the carpet and throw them off all the colors and the shades and how the dye bleeds into the fibers.
Yeah, we're looking at a project now to try to actually recycle that water. Not there yet. Been looking at it for years, and water was cheap, couldn't make the economics work out. So water's more expensive now than it was 10, 15 years ago. So might get a project to work out. I don't know yet.
Would the steam gasifier require more water?
Yes, the steam gasifier actually does consume about 1,000 gallons per day, given our basis.
So if there were gray water from the plant that were suitable, it could possibly be made, used to make the steam, or that water, depends on how. My perception is your heat exchanger, you don't want to crud it up with junk that's going to foul your surfaces. You need very clean water to make steam. But,
But you could have some kind of filtration or something, couldn't you? If you were using gray water, some kind of purification, if it were cost effective.
Yeah, that'd be the problem up there.
my perception is you use a sand filter, and then after you've knocked out your solids, you then go for ultrafiltration or something like that. Then you've got your waste products on your sand. Was that, what was the second one? You use a sand filter. The ultrafiltration usually washes the membrane system. You have to backwash it, but it's pretty all over. Yeah, your part of the mass balance is essentially certain areas with water restriction. If something's going to use incrementally, how much more water do you use based on what the plant's already using?
It sounds like pointing out the water balance as well as the energy balance and the pollution emissions is going to be a nice facet, a nice touch. Especially in California.
The only pollutant you have is CO2, which is sort of a pollutant, and NOx, is that it? So you think, are there other things that in there?
If your SynGas completion, if your conversion to SynGas is not complete, do you emit any really interesting pollutants?
Organics, I mean.
From post-consumer carpet waste.
Right. I mean, I was thinking there be some organic, yeah. I mean, something.
So the SynGas conversion is complete.
Yeah.
Guys, I have a question.
And you can probably track to see what would be the most likely interesting organics to come out of there, and then you can see how noxious they would be.
Yeah, considering the complexity of some of the components of the carpet, considering incomplete combustion would be,
Probably a good
interesting
thing.
for sure.
Yeah.
Yes.
Something that kind of interesting, we were kind of talking about in our little circle here was, how much of the material, the fiber that we're putting in here to feed the system is being consumed to generate the heat for the gasification, and how much of the carpet is being consumed in the production of syngas? Basically meaning you're going to have a syngas composition like it's CO and H2O, and then you'd have a CO2 composition. But it's kind of interesting to know that the basis that we're burning generated heat, we're not getting any benefit from. It's basically a loss in the system. The syngas is what we want to produce. How much of, where's it kind of going? Breakdown of that material.
No physical characteristics of gas fire. Walls of the gas fire.
His question was as far as like what percentage we're using
Flip back to the components of the carpet again. Wait, that slide. I remember from some years back that phthalate compounds could possibly have some problems. And it's one of the few things that basically, more than 20 years ago, we accidentally gassed a bunch of operators at the Exxon plant in Baton Rouge with phthalates, and they were choking. Pretty nasty stuff. I strongly suspect that breaking it down could have breaking that PET down could possibly cause you some pretty nasty air pollutants. You know, is there a way to get the PET out before you do the rest of this?
If it turns out that, if we were able to investigate and see if that was a potential cause for some particularly nasty pollutants, then that would definitely be something to look at to see if we could remove that before it's sent to the gasifier.
Well, what is phthalate? Is it, I mean, it's not all hydrocarbons, is it? What is it?
Polyethylene?
I'm sorry?
The PET, is that what we're talking about?
Yeah, what is it?
It's polyester.
It's a type of carbon fiber.
It's all carbon, oxygen,
So it's all,
hydrogen.
so it's a carbohydrate.
Yeah, it's the same thing water bottles are made of.
Why is the nylon 6 all removed?
It has a lot of value, and it's a,
Okay.
We do other things with it.
Yeah.
Okay.
We can recycle nylon 6, and but nobody's come up with a process yet to recycle nylon 6,6 or PET. So that's the reason we did gasification, is to have a home for the other types of carpet fibers that we can't recycle. So that kind of goes back to the other question too, is I don't want to separate out the PET, I want to get rid of it, because I don't have another place to put it. Now, we're looking for another process to somehow do a cradle-to-cradle recycling of PET and nylon 6,6 also, but we're not there yet. As an industry or in Shaw Industries, we're just not there yet. We have a process for N6. We can keep nylon 6 in a circle forever. I mean, if you give it back to me, I can turn it right back into nylon 6 again. So, that's kind of the reason we did gasification and waste to energy, is find a home for PET and the nylon 6,6.
Yeah, as far as nasty things from incomplete combustion, terephthalate is a candidate, the nylon 6,6 is a candidate, and the styrene from the DSBR. With really incomplete combustion, you can see benzene, which would be, that's on the EPA hit list.
Well, if there's any nitrogen around with this temperature, can you get sign on that?
I was thinking you can.
I was thinking that
Nylon
styrene
66.
butadiene would take, could cause styrene, could cause cyanide.
Yeah.
I'm glad I didn't listen to this bunch before I started the project.
Yeah, take it easy, I gotta go back to work on this stuff on tomorrow, okay, guys, easy here.
Yeah, and maybe you can offset that by watching your combustion temperature.
And that's what we do. You have to control, you know, the SynGas goes into, depending on the unit you look at, into a combustion tube that runs at 2,500 degrees. And pretty much all the bad stuff's gonna get destroyed there. And then there's a redox burner after that whatever doesn't get burned the first time gets burned the second time. So it winds up being really clean.
Right.
Yeah, so we don't see any of the stuff you guys are talking about. Now, it might be in the SynGas. Now, it might be in the SynGas, but I don't measure that too.
We measured the SynGas composition, but we gasify it. The site he was just talking about is a different site. The first one we sampled, we ran at 1,700 degrees, and we ran it directly out of there, we could see. And most ideal SynGas composition.
That's good.
Just out of curiosity, you guys that work in this area, how easy would it be for a student to get information from you? Is it pretty proprietary?
They've already been down there.
Okay, so
Yeah, they came down and toured our gasifier.
what about the lab setting, where you're testing some of those things in the lab setting?
We hired out, just hired a testing company.
The results, could they get a hold of the results to use in their presentation or in their study?
Yeah,
Oh, didn't we get them?
everything they asked for. Yeah, I give you guys everything you asked for, didn't I?
Your present method at Shaw is just to burn the stuff? Is that how you get rid of it?
Yeah, gasified.
Oh, you gasify it. You got, already got a
We
gasifier.
got a gasifier and we've got a boiler. We're starting up the boiler right now, so our goal is to compare the two because we really don't know what's best. So we built the gasifier first, thinking it
By
was
the way,
best.
I think y'all did a great job.
We're doing the boiler.
No, we
As
kind
soon
of
as it
jumped on
starts,
it.
gets running, we're gonna.
That's important, otherwise, the whole point of this was to use you guys to bounce ideas off of the
It's okay, I honestly thought some
Burn it anyhow.
You guys could ask these folks too, when you're visiting a plant like this, you can ask them for resources on where they get equipment, like the boilers and some of the other equipment. They have catalogs, they have websites, they have sales reps for different companies. You can ask them contact information. And you can get a hold of those sales reps and use them as a reference and say, hey, so-and-so talked about how you're working on a school project, can you give me some pricing and stuff? And then you can incorporate that into your economic analysis. Those people are pretty easy to get a hold of, and if you explain to them that you're working on a school project, they're pretty usually forthcoming with information, and they'll give you something, no problem.
That's a good, probably contact me. Yeah, I say contact me.
And these sales reps,
Sometimes
guys,
it's, I've been, in defense, even with me, they're a little cagey sometimes. They have a little burden of, are you, they don't want to waste your time, don't waste my time unless you've got millions of dollars to spend.
but whatever information you can give them,
Oh, yeah.
then they can even call, they can Google something and get some competitors. And so if you get a, I mean,
I can send an email for you too.
yeah, you could get them to send an email, or you could say, hey, so-and-so told me to call you. And then if they give you the runaround and say, I really don't have time for that, then say, can you give me the name of some of your competitors? Because I was maybe thinking that they can give me some information, and then they might give you something.
Well, you got you a good project there.
Remember maybe like 15-year-old papers where they were.
That's a good idea.
Think that's it? Hey, let's give this team a clap.
When are you guys gonna be done? When?
Tuesday right now, next Tuesday.
Next Tuesday, really?
With the economic analysis and everything? I would give it a little longer. Before graduation. So you guys got another semester to go on this, though. You guys got to look at the fall, right? Is this a 4:30? Is this the 4:30 class?
No, we're all graduating.
Are you graduating this semester?
Is this a wrap-up project, or will this project continue with the next senior design group, Dr. Henry?
I guess that's Dr. Henry.
No telling. Can't predict the future. Whatever's interesting, next year we do.
Well, it's really good. I enjoyed it. Plus, I think I learned a few things, so it generated some more work for Josh.
Good job.
Thank you all for
Yes.